Question 14. This one was actually pretty early, and there were still, this was a hard problem. It was placed very early, but it was still quite hard. Okay. So we notice that this set, we can, just for the sake of like making it easier to read, you can reorder them according to size as such. And so really what this set is it's the set of divisors of 12. It's a set of all numbers which divide evenly into 12. And so now I'm going to do something just to make this easier to look at. And I'm going to put these numbers onto a 3x2 grid. Okay. And so these are the 6 numbers that we have in our set. This thing is useless to us now. Okay, so we have this set of 6 numbers, and then now we're trying to figure out the number of ways to order them such that A comes before B whenever A is a divisor of B. And so we have quite a few relations of this sort. We have that always 1 has to be before 3, and 1 has to be before 2, 2 has to be before 4, 2 has to be before 6, 3 has to be before 6, 4 has to be before 12, and 6 has to be before 12. But the way that I set up this table, it's actually that anything that's to the right or to or above has to be multiple. Basically, if A divides B, then on this table, we have that B is either to the right or above. It can't be below, and it can't be to the left. And so now we start building out our set, our series of 6, our ordering. So we know that has to start with 1. That's fairly straightforward because 1 divides everything. And so therefore 1 has to be first. And 12 has to be last because everything divides into 12. So 12 has to be behind everything. And so now we do some casework. So case 1, what if we put 2 into the second spot? What if we do that? 2 is the second. Actually, I'm going to do the other case first because it's simpler. Okay, what happens if we put 3 in the first spot? The second is the second number in the order. Then that means that we have 1 and then 3. And then, so we're left with 2, 4, 6, and 12. And so 2 divides all of those numbers. So 2 must be the next one. And then for the remaining ones, we have the choice of, we can either put 4 or 6, and then we finish by putting the other one and then 12. So this gives us a total of 2 solutions. And then for case 2, we say that what happens if 2 is a second number? And this time, unfortunately, we can't force a certain value to be the third number in the ordering like we had with the 3. So we break it down into further cases. So case 2A is the next number is a 4 after. So case 2A is we start with a 1, 2, and 4, at which point it's forced to end with 3, 6, 9, because 3 divides everything, 3, 6, 12, because 3 divides 6 and 12, 6 divides 12, and therefore must end with 3, 6, 12. So there's one solution in this subcase. And then case 2B is what if 3 is the third number? And in that case, if 3 is the third number, then we have some choices. So we're left with 4, 6, and 12. to plug it back into the sequence. And so we can, it's very similar to case one. We can either put 4 or 6, and then we put the other one and we end with 12. And so there's 2 more solutions here. And so adding it up, there are 2 plus 1 plus 2 equals 5 solutions. Yeah, this is not a very good problem. There is no clean way to do this. And you kind of just have to bash it out. The 2 by 3 table is very important. It's very clean though. When I was writing it out, you could draw it as paths. For example, case 1 is just these paths, something like that. And so you can write it as paths and it's nice and visual. Okay. Any questions?